Hello, my dear students. It's nice to meet you again. This is a wonderful term. Are you ready for this? Yes, we have a wonderful lessons for this term. Let's see the first one. It's about chemical reaction. Chemical reaction, it means it's a breaking up bonds in some molecules of the reactants and forming new bonds in the molecules of new resultants. It means the products from the reaction. Chemical reaction, my dear, depending on reactants, also depending on resultants. Yes, don't forget. This is we'll study it for the all the term reactants, resultant. It means the product. All chemical reaction, it has a types. Yes, it has a many types. Mention the types of the chemical reaction. As a beginning, thermal decomposition reaction, or substitution reaction, or yes, oxidation and reduction reactions. My dear, thermal, it means using heat. We need a heat to make many chemical reactions. Also, substitution, it means replacement, and it has a different rules, and this is well studied part step by step. Oxidation and reduction, depending on for its name, oxygen and hydrogen. This is not only, but we'll study it after that. This reaction, it's crystals of the salt. When I start to burn the salt, we'll see it tries to decompose into small pieces. These pieces, it means we have new product will start to be formed. Now, the product may be in the form of the gas. As you see, the gases start to be evolved. But this is not only the product. The product has a different shapes. For the gas, maybe for the crystals. If I see the crystals, the color is changed. Now, don't forget the color for the reaction. I want to know what is the name. I use substance to help me to do that. As a litmus paper, if the color is changed or no, maybe change it to red or blue. And the crystals also change its color. So, chemical reaction depends on the reactants and resultant. Now, what about thermal decomposition reaction? I know it, my darling. Thermal here, it means they are reaction which involve breaking up of the compound. By what, my dear? By the effect of the heat. Thermal, it means the heat. I know it's very important to know this question. Another one, if I get an element as a P, but has other element as A and B, both of them, they are a compound. If I want to decompose them, I can do that? Yes, can be decomposed into the first one, element A, only, alone. Also, element B, alone. Do you know why? Because decomposition, breaking down compound to its component. It's great to catch it. Don't forget this triangle. It means what? It means heat. By heating, decompose a compound. Now, we have to prepare for breaking down compound. What I need to do that? You must present flame. Yes, why? It's benzene flame. Why we need it? Because thermal, it means using heat. All of these reactions need a heat. Also, we have a holder, and this is the material that I need to be broken. It's a calcium carbonate. I know it. It's shape, as you see, crystals. Yes, I add it to the holder and concentrate. Can I breaking calcium carbonate by heating? Yes, Yes, I can do that. But I need for this large amount of heat. So I bring another, yes, benzene flame and directly point to these crystals. Heating continue. Heating continue again. Why? Because I want to breaking down CaCO3 to CaO and the carbon dioxide. Can I say that? Yes, but I need a long time. The flame is concentrated for these materials from the time. After that, nothing. Observe it. I need a more of heat because it need a large amount of heat to be completely thermal decomposition reaction. Also, I stir it from the time to time. Now, after 10 minutes, I can see the color start to be changed, but it's not completely. I need a more heat, and we can do that. Concentrate heat directly to it and wait. I am in waiting. This is by stirring from the time to time. CaCO3 must be calcium oxide and the carbon dioxide. I am waiting carbon dioxide. It's wonderful to catch it, but I need a long time. I need a much amount of heat. It's not easy to do that because it's hard crystals. CaCO3. Yes, decomposed to CaO and carbon dioxide. But after long time, decomposition reaction is not easy. Yes, because it depending on the heat. But after 45 minutes, yes, the heat increase. Now the material is changed to CaO and the carbon dioxide gas. It's wonderful. Now, red mercury oxide. I know it. Red mercury oxide, it means what? Yes, it means 2HgO. This is red mercury oxide broken to 2Hg plus O2. My dear, HgO has a special oxygen. Now, if you want to breaking that, make it away to each other. So will be 2Hg. This is not only. It changes from the red color to silvery color. Wonderful. My dear, don't forget, we have red color, it changes into silvery color of mercury. 2HgO will be 2Hg plus O2. It's great to see that. Another one, yes, red, silver. Other question, copper hydroxide. Yes, the formula of the copper hydroxide, Cu, open bracket, OH by 2. I want to change it to CuO plus water. Yes, we can do that. Get one oxygen from O and give it to copper. The result, CuO. This is only? No, I need the heat. Don't forget, this broken need a large amount of the heat. Good. Now, the color, blue color, will be black. What is the black color? Black precipitate. This is CuO. We can say black metal oxide. Black metal oxide, it means copper oxide. I know it. Important to know we have a color, my darling. Yes, zinc hydroxide. I think by the same steps. Now, I want to change Zn, open bracket, OH by 2, will be ZnO plus water. Now, what happened? Explain, my dear. 2 oxygen, get a 1. Give it to what? Give it to zinc, will be ZnO. What I need? Good, my dear. I need a heat because we work through thermal decomposition reaction. Has a color? No. Yes, it's okay. Another one. Copper carbonate, CuCO3. By heating, it will be what? I have 3 oxygen with group of the carbonate. Get one oxygen and give it to couple will be CuO. And don't forget, we have a triangle. This triangle, it means? Good. It means heating because we work through thermal decomposition reaction. The color, is it changed? Sure. From green color, CuCO3, to black color, CuO. The color, very important, green to black. Oh, also, we have a black color, black metal oxide. I know it. And I hear it of students say, copper oxide, CuO. Wonderful, this question. I have a carbonate here, as you see, about 35 grams, but it has a 30 only. It's okay. We can do this experiment, as you see, directly in our home because it's a safety experiment and hasn't any problem. Now, I put the pot on stove and I light the heat. Don't forget the heat. And I know you work through good thermal decomposition. It's a safe reaction. Do it in a dough. From time to time, try to stir it. CuCO3, CuO plus carbon dioxide. I add 30 grams, will be 20 plus 10. Keep mixing around the heat, radiate through so it's not just. Look at the color, it's not changed yet, but it stay green. From time to time, I try to stir it. Why? You can see northwest in the dark. Now, the color start to be changed. Yes, a part is black appears. So, it's more black. So, more black again. Completely black. You can clearly see 90% CuCO3 will be CuO, black metal oxide. It's easy to say that this is the color of now. CaCO3, calcium carbonate, will be CaO plus CO2. One oxygen from the three added to the calcium, CaO. We need a heat. Don't forget the triangle. This triangle is very important to tell me that thermal decomposition reaction. Now, the color from the white to black, yes, can be changed to black or different colors. The color is very important for the chemical reaction. I get CaCO3. This is my reactants. By heating, give me my product, CaO. Not only carbon dioxide gas. Wonderful to catch this question. Another one. ZnCO3, zinc carbonate. I want to change it to zinc oxide plus carbon dioxide. All equation by the same steps. Now, catch the 3 oxygen atoms. Yes, get one and give it to what, my dear? Give it to zinc. It will be ZnO, zinc oxide, the gas carbon dioxide. I have something wrong. Yes, it's heat. Don't forget it. Thermal decomposition reaction. It's wonderful to catch zinc oxide by this method. Yes, another one? Good. Sodium nitrate. Yes, I know it. Sodium nitrate is a special material. Sodium is active. Sodium can be changed to sodium nitrite, NaNO2 plus O2. Oh, why it's difference? Look, sodium nitrate, for this case, have 3 atoms of oxygen with nitrate. Sodium is very active element, so not decomposed for its compound. What happened? It's a melt. Melt here, it means just one oxygen fly and the other stay for the compound. Now, by what? By heating. 2NaNO3 by heat will be 2NaNO2 plus O2. Sodium nitrate to sodium nitrite. Wonderful. But look for this. The color is start of here white color. It changed it into yellowish color. It means white to yellow. the color is changed? Yes, because the reactants here, sodium nitrate, broken into sodium nitrite and oxygen gas evolved. Catch it, my lover. For the other question, potassium nitrate. Also, we know potassium active element. What happened? It's like sodium, not decompose, but melt by the same steps. One oxygen evolved alone, and the other stay 2KNO2. Wonderful to know it decomposed to nitrite for the case of sodium and potassium. I don't forget the heat because I work through thermal decomposition reaction. Wonderful. Fly to the other one. Yes, my dear. Sulfate, CuSO4. Yes. How can be CuO and SO3? I can do that by the same method. My method, it means I have 4 oxygen atoms. Get a 1 to the copper, CuO. It will be SO3 sulfur trioxide. Copper sulfate decomposed by heating to copper oxide and sulfur trioxide. What about the color? The color, as you see, from blue color copper sulfate to black. Yes, we understand. This is about the third equation, had the black color of copper oxide. Directly we say copper oxide, black color, if it decomposed by heat. Color is very important for the equations. This is copper nitrate, and we'll see what happened through that. Let's see now. Blue copper sulfate, as you see, when it's heated, it's melt, its crystals melt one after one and start to be cover or tube. Yes, it's a boil now. Do you think what happened if it's a pile? We know if I put litmus paper, the color of it changes to red. This means the gas that evolved its acid, SO3. We know it. Now, the gas stay. Look at this. Yes, the color will be black, copper oxide. Wonderful to know. Copper sulfate decomposed by heating to CuO and SO3 evolved. Another one. Look at this. When I get magnesium sulfate, group of sulfate contains 4 oxygen. Directly we say, if you want to be MgO and SO3, get 1 oxygen from these 4. Good, my dear. Give it to magnesium, will be magnesium oxide. What is the gas? We have acidic gas. This acidic gas is SO3, sulfur trioxide, acidic gas. Another one. Yes, I'm sure I need a heat, so I can't forget this triangle. Fly to zinc sulfate. Now, zinc sulfate, ZnSO4, will be ZnO plus SO3. 1 oxygen fly to zinc will be ZnO. Where is the heat? Yes, we have a heat. Tell me, my dear, why we need a heat? Thermal decomposition reaction. I like this equation. Another one. Look. Can you differentiate between the gases evolved? Yes, the gas, carbon dioxide, gas, oxygen. We can do that? Yes, carbon dioxide evolved from the carbonate. Oxygen is evolved from the nitrate. Now, if you have to tube and try to differentiate, what you do now? By adding what? Glowing splint. Yes, when you add glowing splint, for the first one, look, carbon dioxide, oxygen. Now the color of carbon dioxide will be put out. Why it's put out? Because carbon dioxide is not burned and not held for burning. But the oxygen is staying burning. Why? Because we know oxygen is not burned. Yes, but help in burning. This is a method. Also, we can add litmus paper. The color will be changed red for carbon dioxide. No affection for oxygen. Wonderful, my dear, to know the difference between carbon dioxide and oxygen. Fly, fly, fly to what? Yeah, we have substitution reaction. My dear, substitution, it means replacement. They are the reaction which depend on the activity of the metal, where the element which is more active substitute the less active one in another compound. I can know that by the chemical activity series. Chemical activity series, it means it's arrangement of the metal element in descending order according to their activity. Oh, how can I know sodium more active than barium? How can I know that? It's very easy to look at this table. K, Na, Ba, Mg, Al, Zn, Fe, Sn, Pp, H, Cu, Hg, Ag, Pt, Au. These different elements are arranged from top to bottom. It means the most active one, potassium. So potassium can be replaced by sodium, can replace sodium, sodium replace barium, barium replace calcium, and so on. It means the upper one can replace the lower one. My dear, we have hydrogen. Hydrogen, it means the group after the hydrogen, they are weak element. It's difficult to replace anyone for its acids. So you must know this chemical activity series depending on the activity for element. How can I know? Let's see that. Look, for the first one, sodium added to the water. It will be sodium hydroxide plus hydrogen plus heat. How can we do this reaction? Sodium is active element. This active element need to breaking down or to replace hydrogen of water. It will be now sodium hydroxide plus hydrogen plus heat. We can't do this experiment? No, it's dangerous, but we can do it. We have a movie about this. Look, if I get also potassium plus water, potassium is active element, can replace a hydrogen of the water. Hydrogen evolved and will be burst and give pop sound because it's dangerous. Heat is evolved. My dear, look, if you want to make a reaction, you need a special place to do that because it's dangerous. Look at this. This is flask and jar and a special place for keeping sodium. Sodium and potassium are kept for this special place. Why? Because they are dangerous. It has safety for each part. Sodium, potassium, and also many elements for the group 1A can react with air, so must be covered well and kept in this special jar. The special jar, safety for each part. Now, what we can do to obtain sodium away and we obtain potassium away from this jar? To do, look at this. From time to time, they are stay away of oxygen. So they are covered from the top. The sodium, as you see, this is pieces of sodium, It has metallic shape. It's luster. There is liquid inside the jar. This is not any liquid. This is not water. This is kerosene. Yes, we keep sodium under surface of kerosene. Why? Because it's active metal, can react with the water, can react with the air. This is sodium metal. When it gets out, as you see, it stays in air. It starts to react with the water vapor from the air. So, I hold it well by my holder and I try to cut a small piece of sodium. It's dangerous to get this big piece. Why? Because it can burst. When it's a burst, it gives a large amount of the heat. Now, we have a beaker and I try to add a piece of sodium. Be careful and look. When I add sodium to this water, what it will be? What happened? Na added to HOH. HOH, it means water. It reacts fast and very fast, and after that give heat and large amount of heat, and the gases evolve. It's great. This is the first reaction. Sodium hydroxide is formed and the hydrogen make pop sound. Now, I can do this reaction in my home? No, it's dangerous. Sodium is very active. Potassium is very active. So must be away of my home, away of anyone to use it. It's difficult for usage. Now, we'll try to do this reaction for the other place. To be sure, what is the formation? 2 Na plus 2 H2O to be 2 NaOH plus hydrogen. Other piece, but it's more big. You look at the gas. The gas is evolved. Time is scared. Now, I want to make this reaction away of laboratory because it's difficult. I get large piece of sodium and I add to the beaker of water. Look what happened now. Yes, it's burn. And they give a hydrogen gas. It's dangerous. Do you think this is happen with other large piece? Get a large piece. Now, I'll try to put it and move away. Move. Fast, 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 and fast. Yes, we move faster. Why we do that? Because it make a burst. When a piece of sodium, its size increase, the burst increase. You see, it changes to sodium hydroxide and burn the area that's around this experiment. We arrived to the end. I hope you too enjoyed with the wonderful and the fantastic lesson. I want to see you soon. Please don't be back. I am waiting you. Thank you and goodbye.